Alright guys, this is Mr. Hover. Wanted to walk you through how to approach at least part of the handout for today. It's a little bit challenging. There's a lot to this. It's only 5 problems, but I think it's going to take you some time to work through each of these. So read the instructions at the top carefully and make sure that you do follow through on each of those parts when you draw up your force diagrams. So I'm going to walk you through what the force diagram will look like for object B, which means we need to draw that over here. So I've defined my system as object B, put a dot right in the middle, and I need to think of the forces that act on object B, and we're assuming that this whole thing is moving constantly to the left. Okay. So most of these, you're going to start with the force of gravity. All of these things occur near the Earth. So instead of putting FG, the instructions say to use agent-object notation. So one way to think about gravity is it's actually the Earth pulling on an object. Okay. So instead of putting FG here, I'm going to put force subscript Earth on B. Okay. Now in the back of my mind I'm thinking, yeah, I'm talking about the force of gravity. So if you want to annotate that in parentheses, not a bad thing to do. So the Earth would be pulling object B downward, and object B is compressing this surface, so the surface is pushing back on B. So I need to include that as an upward force, and I know that those two forces should be balanced because there is no acceleration in the up-down direction. So in agent-object notation, instead of putting normal force, I'm going to put force of ground or surface, whatever it happens to be, on B. Again, in parentheses, I know that I'm really talking about a normal force, so I could indicate that. Alright, so let's think about what's happening in the x direction, the left-right direction. Again, I'm focusing in on object B. So even though there's a hand pushing object A, what's really pushing object B to the left is object A. A is pushing on B to the left. So I'm going to include that as a force. Force A acting on object B. Now, we see that this is constant velocity, so we have to think back about what we know about force and motion. Constant velocity means no acceleration, and if there's no acceleration, the forces have to be balanced. The net force has to be 0. So I have to conclude that there's a force to the right on object B that's balancing the force of A pushing B to the left. And I would have to assume that there's probably some friction present, right? At the surface here, there's some resistance. Remember, we talked about the fact that with friction, surfaces are really kind of bumpy and ridged on a microscopic level, and to slide one object past another, you've got to kind of overcome those bumps and ridges. So there is a frictional force as box B slides across the left. Now, agent-object notation, where's that force coming from? Well, it really is these bumps and ridges of the surface pushing to the right on object B as it slides past. So it's correct to say, again, that it's the force of the ground or the surface on B. But we might want to note that it's a different kind of cause, right? This is kinetic friction. So this is a lateral force from the ground on B, as opposed to the normal force, which is an up direction force on object B. And that comes from this being pulled down by gravity, and the force responds by pushing back up, kind of like a spring would. So we've got our 4 forces. It would be correct to say that those 2 forces are equal in magnitude as well. So I'm going to indicate that with some hash marks. Now, the summary down below, what I want to do is write a statement that kind of summarizes what's happening. And the instructions say it can be an equality or it can be an inequality. In this case, I'm expecting an equality when I compare the forces. What I mean by that, in the x direction, we've got force of A on B equal in magnitude, or equal in size, so I'm going to use the absolute value bars here. I'm not going to worry about this being a negative force, I'm just worried about the size of that force. Must be balanced with, I'm going to use the abbreviated form, the kinetic friction. Okay? In other words, this force, same size as this force. In the y direction, the normal force magnitude balances the gravitational force magnitude. Equal in this case, again, because there's no acceleration in either direction. So you may find, and you will find, in some cases you will not put an equal sign here. You will put a greater than sign or a less than sign, and you might even have multiple forces on one side of your equality or your inequality. In other words, if there was another force pushing to the left on B, I could include that, on this side of the equation. So they get a little bit more complicated, but please do use agent-object notation here. When you summarize down here, you can use the abbreviated form. You don't necessarily have to use agent-object notation throughout. So I'll leave that to you to figure out what's going on with object A. Again, you shift your focus to this system, start with a dot, and you draw the forces. Good luck. Have fun. Have a good day.